Hello again. In this lecture, I'm going to talk more about electric potential energy. So, what is energy in the first place? Energy, by definition, is the ability to perform work, which you might remember that work is equal to the force times the displacement. That is, force enacted over some displacement d. There are two main types of energy. First, let's talk about kinetic energy. Kinetic energy is when you have a particle or an object of some mass m moving at some velocity v. This object has kinetic energy because it is able to perform work. We know this is true because if this object runs into some other object with mass, then this object will move. So a force must have acted upon this object. This force, we also know, must act over some distance. Since the object is in motion, kinetic energy is a type of realized energy. On the other hand, potential energy is a sort of stored energy. This means that the object isn't in motion. It isn't currently realizing its potential. A good example of potential energy is when you have a block of mass m attached to a spring that's been compressed, such as this. We know that this configuration has potential energy because if you release the block, the spring will decompress, causing the block to move this way. This means that the spring is enacting some force onto the block over some distance, so we know that the spring has potential energy. Energy can be stored in other ways, such as in a field. This means that gravitational fields and electric fields have potential energy. This is where electrical potential energy comes from. So what exactly is electric potential energy? Let's say we've got a charge plus Q sitting here, so we need to think about the work that this charge can do. It doesn't make a lot of sense just to think about a charge in isolation if you're thinking about work. So we'll add another charge over here, minus Q. This makes a lot more sense because we can think about the relationship between the two charges. As we'll see, electric potential energy is always defined in terms of a configuration of charges, so we have more than one charge. Electric potential energy is the amount of energy it would require to walk from infinity, carrying this charge, negative Q, all the way to its final position, here. We know that some work must be done because in order to move from here to here, we have to oppose the force, the attractive force, between these two charges to keep this charge from flying straight toward this charge. There's a formula for this electric potential energy, and it looks like this. U, E, which is what we call our electric potential energy, is equal to constant K times the first charge times the second charge, divided by the distance between them, r. Electric potential energy is a scalar, so it has magnitude but no direction. So let's try a calculation. Let's say you've got a charge plus Q, some distance 3m, 3 meters that is, away from another charge minus 2Q. Can you calculate the electric potential energy of this configuration in terms of the constant K? Let's give it a shot. U equals K Q1 Q2 over R. So we end up with K times the first charge, 1 coulomb, times the second charge, negative 2 coulombs, divided by the distance, 3. So we get that the electric potential energy is negative 2/3 K. So what about units? Electric potential energy is a type of energy, and all energy is measured in joules. Other units of energy would be calories, like in food, or kilowatt hours. That's all, folks.